Hey everybody, this is Jason over at the Children's Museum of Houston, welcoming you to the final activity of the Geology unit, where we're going to take a bit of a divergent path. So far we've really been talking about rocks, minerals, how rocks and minerals are made through geologic forces, even talked about core samples, but right now we're going to talk more about an instrument that measures wind. It's called an anemometer, and this is an example of an anemometer right here. And it's very, very simple to make, and your kids are all going to make one and take it home with them to show their parents how an anemometer works. But first, what does this anemometer have to do with geology? Well, remember, geologists are interested in all types of rocks. Igneous rocks are made from volcanoes. Metamorphic rocks are made when igneous or sedimentary rocks are subjugated to an intense amount of pressure and an intense amount of heat. Sedimentary rocks are first made through erosion. And we talked about water erosion quite a bit in the first activity, but we also mentioned wind erosion. Geologists are interested in understanding why certain areas are eroding quicker than they used to, possibly, maybe because there's more wind, or why they're not eroding as quickly. There's less wind. So they can use an anemometer to actually measure the wind speed, measure the amount of wind that's occurring, and see if that's what's causing erosion to happen faster or slower in certain areas. So if you look at this anemometer and you blow on it, you can see it's spun. Spun a little faster. Spun a little slower that time. I'm losing my breath, I guess. But what we're going to give you is a fan, so you can actually put it next to that fan and you can measure the revolutions per minute by marking one of them with a dot using a Sharpie or whatnot and seeing how many times that Sharpie goes by in 15 seconds and then timesing that by 4, and then you have revolutions per minute. So you can then determine how fast it's moving. But making one of these, it seems a little flimsy, I guess, but making it is actually pretty fun and simple. All you're going to need is 5 Dixie cups. 1 Dixie cup makes the hub. These other 4 make these outer parts that start to spin. You're going to need 2 straws. As you can see, the 2 straws are forming an X. So they form an X like this. And the way they form that X is you're going to punch a hole here, punch a hole here, punch a hole here, and punch a hole here. So you're going to get those 4 hole punches, and then you're going to just really shove the straws through. Now, sometimes it's a little difficult to shove the straw through, so you might have to flatten it a little bit on the ends to get it first through and then get it inside. Once you get the straw shoved through, you're going to flip it over, and you see where this hole is, where this pencil's going through? Well, first you're going to make an X using a Sharpie to make that hole. Then you're going to go ahead and use this golf pencil to stab into the cup to make a hole. After that, you're going to take a pencil, looks like this. You're going to shove it into the hole eraser first until it hits the straws. Then you're going to take a T-pin, looks like this, looks like a T, and you're going to push that in until it goes through both straws and into the eraser. You have to be careful with the T-pin because if you put it in too tightly, it won't spin. So again, they are making something, even though they're all going to make it pretty much the same, there might be iterations. They might have to adjust things. They might have to change some things here and there. And then the final cups, basically you punch a hole into the lip, you put 1 cup on the one end of the straw, tape it down to secure it, and then each cup is going to go from the mouth to the back, mouth to the back, mouth to the back. So that when you blow on it, the air is going in one direction, flowing through it and moving them all about. Okay? That's a pretty simple instrument to make. And what's great about it is when you have something like this, you can tie together a couple of different types of science. Right here you're tying in weather as well. Why does wind blow? Why is it important for us to measure wind speed? Think about natural occurring things that occur. Storms, hurricanes, tornadoes, things like that. Meteorologists, people who study the weather, use things like anemometers to determine wind speed, more sophisticated than this, of course, to help us understand, okay, there's going to be more wind today. We should watch out for that. Things like that. So you're kind of mixing a lot of different things in with this anemometer. You're mixing in some geology when you talk about how sedimentary rocks are formed. You're mixing in some meteorology when you're talking about what wind measuring devices like this are used for. And you're also showing making, like how people make things. Even though we lay out step by step how to do it, kids can try to do something different if they want, to make it move faster or to make it even move slower if they want to. So don't allow them that chance to explore the materials and build something that they want to build that's unique to them. Okay, so ending geology on a kind of a fun note. They get to build something, they get to learn a little bit about weathering, they get to learn a little bit about weather, and they get to learn about geology. Again, if you have any questions on anything that we talk about, go ahead and talk to your supervisor. They'll shoot me an email and I'll answer anything you got for me. This is Jason signing off. Hope you guys have a good day. Bye.